Okay.
So thank you for the introduction. As mentioned, my name is Hańca, and I work for Robotek AI, a Polish company that is doing a lot of different things with Open3D engine, all around simulation, but doing from very small simulations like simulating a single sensor up to orchestration of many different robots in one area, trying to work with each other. So yeah, the first disclaimer is about the slides. You can see a small point saying that slides are confidential. Of course, those are not. I just couldn't find another template in my company. And it's also a disclaimer about everything I'm saying. So basically, I'm saying things about Open3D engine as I see it, as we see it in a company. So when I complain a bit about some things that don't work, they don't really work for us. We are trying to fix it. If I say things that you believe are incorrect, it's also perfectly fine because I started working with Open3D engine slightly more than a year ago. So there are still many gaps to fill in, also in terms of simulation that I'm doing on a daily basis. So I will just start with explaining what is simulation and why Open3D engine. And then I will jump directly into Open3D Extras repository, which is a base for our gems and templates that are used in simulation. I will give you a brief introduction on how to build a project from the template, because I hope this presentation will land somewhere on YouTube, so people will be able to use it as a guide, people starting with the simulation. As someone who attended ROS2 this year, I know that there was a lot of interest about Open3D engine, many questions how to start with Open3D engine. So this is a point where I want to answer those questions. Same for ROS2 Gem. Basically, we try to keep the documentation up to date, but I will also briefly explain the most important concepts that were there when we designed the gem and when we developed all the components. So finally, we'll jump into some editor. I hope it won't make any troubles on my notebook. So we'll try to run the project, modify it a bit, just to show you how we do it for simulation, what is important for us. What I want to also show is how to import robots, because this is a big part that helps us a lot with many robots being available online. And finally, something most interesting for most of you, I guess, so C++ examples. I had difficulties when I was invited by Naomi to present Open3D engine. It's always difficult to find a right balance between something complex and something simple. So I hope this will be interesting for people who are developing Open3D engine on a daily basis. So I will also show you some videos, and I will also explain how to use ROS2 within ScriptCanvas and Lua, because we also have this possibility. All right, so I asked ChatGPT yesterday why simulation, and actually ChatGPT answered the question in a way I would answer myself. So I simply copy pasted it, because this is something we have in our daily basis contact with a client. The first and the most important thing is safety. You don't want to test failure scenarios in the real case, in the real world. So this is something we simulate. We can reduce the risk because, of course, playing with robots that are not really tested in real life might be dangerous for many people. And simulation saves a lot of time, allows to produce plenty of different scenarios. For example, we have a client developing a SLAM system. So with a couple of clicks, with some software that we are providing to this client, the customer can produce thousands of different layouts of warehouses and test his SLAM algorithm. So the same goes for scalability and data collections. That's a very important branch of what we do here at Robotek. Basically, Open3D engine has a great renderer, which allows us to generate realistic data because it's synthetic from the beginning. We can easily generate ground truth labels for machine learning and many other applications. This is also a part of our open source tools that we are giving to the community. So this is something that anyone could actually do using Open3D engine. And this brings me to the answer to the question, why Open3D? From my perspective, as a big fan of open source, this is the main important part. It's open source. The license is not going to change. Something that already happened to Unity recently with huge increase of pricing. It's not going to happen to O3DE, and it's also very important for our clients. It's in C++, which from my perspective, it's nice because I like C++, but it's also very important in simulations because you can directly integrate Open3D engine with ROS2, and this is something we do, and this is something I'm going to present you in a moment. The renderer, which allows you to render realistic data, is important from the technical point of view when we generate data for AI, but also from a marketing point of view. Let's be clear about it. There are some managers that really love pretty images of their robots, so the renderer is definitely helping us out to sell some products. Physics 5 and basically the fact that everything is already there in Open3D engine. We can implement some stuff with Lua. We can implement some stuff with ScriptCanvas even. Basically, the editor is there, material editor is there. We didn't have to do a lot when we started working on simulations with Open3D engine because it was all there. And for us, from our perspective as people working in simulation domain, our main repository is O3DE extras. It's important to mention that this repository is canonical. It goes always together with Open3D engine, so the releases are happening at the same time. And you can always be sure that when you download the code from the main branch, it works together. You have the main branch of the O3D repository, main branch of O3D extras repository, and everything should work very smoothly. For development, sometimes it's not the case. Sometimes we are trying to catch up with the fast changes in the main repository of Open3D engine. That's why development branch is always a bit more risky. However, for the main branch, there are not that many problems. And there are multiple gems related to simulation. The most important one is ROS2 Gem that collects everything related to ROS that can be used directly from Open3D engine. Besides that, there are small gems to support the development, small gems that were created mainly to make it more usable if you want to reuse the same assets or the same project templates, the same projects, the same pieces of code. The Proteus robot, as the name says, it's just a gem with a robot that can be easily integrated into any project with ROS2. It doesn't have any dependencies other than ROS2. The same for ROS robot sample. It's a Husarion robot that can be used to test ROS in any environment. There is a gem with some assets that can be used in warehouse assets gem. There is a gem warehouse automation. It was meant to serve with some additional functions for warehouses. The only thing that is implemented over there right now is a conveyor belt, and the implementation is quite complex, physical. It's not the most optimal part. So to be honest, we don't use it anymore, but it's still there, and we will be most probably cleaning it for the next release. And the last gem with just assets, it's warehouse sample, is a very small warehouse, very simple. It's imported from Gazebo, so it's familiar to people who work with Gazebo. It doesn't look that good because it's pure Gazebo with no extra materials and all the data that is necessary for Open3D engine to render stuff nicely, but it's very lightweight and it's very easy to use for a start as a simple test environment. I use it myself very often. There are 3 project templates. Most probably for the next release, we will be reducing that to 2 project templates. The first one, ROS2 project template, is just a simple template that has one Husarion robot. It uses basically ROSbot sample gem in a small warehouse that can be used to test the connection of your ROS environment with Open3D engine. Just a great starting point, I would say, for people who want to do anything, who want to try anything with simulation. The second template, ROS2 Fleet, it's very similar, but you can use the fleet of robots within the space. Not much difference between the two. So that's why I mentioned that most probably we will be doing some redesigning of the templates to make it simpler and more clear to the users. The last one, manipulation template, it's for robotic arms manipulation. There are 2 levels with 2 different robots. This is something we use on a daily basis also to start, and I will also show you some demos with all those templates later on. There was a talk lately during ROSCON. It was a lightning talk, so it was in 2 minutes format. It was presented by my colleague Michał Pełka, who tried to convince people that you can start and you can try Open3D engine in less than 10 minutes. It's very simple because you just download the package, you start the project, and to be honest, I did it for the first time right after his presentation. I always build everything from source, so I will jump into it in a moment. But what I wanted to mention at that point is that the very important part for the simulation, if you want to use any of the templates, and I guess that would be the easiest way to start working with simulations, is to install gems first. There are some dependencies. If you don't have those gems installed before you create a project out of the template, then you would get some warnings that the gem cannot be found. So you need to go back and forth to install those gems. So first you just go to gems tab and you install all the gems from Open3D extras repository that I mentioned earlier. Of course, from the graphical user interface, you just pull the zip files. Everything happens for you under the hood. You don't have to think about it. And when you want to create the project, then you just create a new project, select the template, and build a project. What's very important at that stage is that you only build the source code that belongs to the project. So you use the editor and Open3D engine SDK that is provided, that is downloaded from the internet. So you don't have to worry about building the big engine with plenty of targets that needs to be built before you run your simulation for the first time. So yeah, that's another slide from presentation of my colleague, just when he was explaining that it's so simple and that you get editor running and it's enough to hit the play button. I would change the name into O3DE time to robot, more than 10 steps, and it comes from the manual that I sent to one of the users over Discord when he had problems building a code from source. I mentioned more than 10 steps because for me it's 12 steps here. The first 2 that are not mentioned is just pulling O3DE extras and O3DE. Next, what happens in lines 1 to 4 is just putting some exports to the shell, because I'm talking only about Linux. This is very important to mention. ROS2 Gem works only for Linux operating system at the moment. I know that there are some people in open source community that managed to run it on Windows. We are officially not supporting it, basically because we don't have the manpower to do that. And we don't use Windows machines ourselves, so it would be very difficult to test it. So back to the small script that's on the screen. The first 4 points are just to be sure that all the paths are correct. Next, it's all about Open3D engine. So the first thing when you pull the Open3D engine from the sources, you need to get Python and you need to register the engine itself. So those are points 5 and 6. And you also need to register gems. This is very similar to something I mentioned earlier, which was just pulling gems from the internet. Here it's registering gems that are pulled as a source code. Next, what happens here in this example, it's I create a project based on the ROS2 robotic manipulation template in line number 9. I configure the project in line number 9. Sorry, the previous one was number 8. And then in line number 10, I just build the project with all the assets. From my perspective, it's very convenient always to build a project name.assets target. If you don't do it when you build the code from source, then all the assets would be built at the start time when you start your project for the first time, and it can take very long, and O3DE becomes not responsive at that time. So we always try to build everything in advance. And this is something we also recommend to our clients. This is the instruction very similar to the ones we are sending to our clients, the ones that work with the source code. All right, so for ROS2 Gem, because this is the topic of today's conversation, I really recommend to head to the documentation because everything is described there, but the most important things that I want to mention that are also there is that the gem creates a ROS2 node. It's done within Open3D engine. As mentioned earlier, Open3D engine is implemented in C++, so we can do that easily. And there are no bridges required for that. And this line is mainly for people who are working with simulations in other engines like Unity, which is mainly implemented in C#. Then, of course, it needs some kind of a bridging, but also Gazebo needs some bridging, some additional layer to link ROS2 with the simulator. This is not required in Open3D engine. Open3D engine also uses everything that's in your environment. ROS2 is kind of famous for using environment variables a lot. Typically, when you create your ROS environment, you build it and then you source your terminal to know this environment. And then you source multiple times, multiple different environments on top of each other, and your final ROS setup can use all the packages from all the environments. This is something similar when you use ROS2 within Open3D engine. You just source those environments, you source your shells with different ROS2 workspaces. And when you are done with that, you can use the same shell to start your editor or to build your code, Open3D engine code that uses this ROS data. From Open3D perspective, Open3D engine perspective, ROS2 Gem creates a ROS2 system components, which is a singleton, and this is a simulation node that handles everything in Open3D engine. If you want, you could create another node, a second node, but we never had a need to do that in our real life simulations. So I believe this is only for very specific cases. And the most important part for ROS2 Gem is ROS2 frame component, which firstly, it serves as a representation of interesting physical parts of the robot, like frames in ROS2 that you can later on use them on a map. You can see their coordinates. You can see how those are linked with each other. But in our case, it also encapsulates the namespaces, and we use it widely. For example, when we have two robots that are exactly the same with the same sensors, we need to change the namespaces to be able to distinguish different streams of laser data or camera data, and we do it with ROS2 frame component. Other than that, all the basic sensors that you might want to use with your simulation are already implemented in ROS2 Gem, like the camera sensor, GNSS sensor, so GPS or GLONASS sensor, IMU sensor is there, LiDAR is there, odometry and contact sensor is there. So the only thing you need to do is to start your simulation, to add ROS2 frame, to add ROS2 sensor, the one you need, and you can already see the data in your ROS topics. I will give you some presentation later on. Yes, and the last thing to mention is that ROS2 Gem implements also everything related to robot control, like twist control and Ackermann control, but also all the tools to manipulate joints and to get to know joints' positions, to control them. There are also some additional things like ROS2 spawner. So it's possible to add more robots, more objects, or anything you might want to add in the simulation from your ROS workspace, from your ROS scripts, so that you can really make your simulation as it is in Gazebo or any other simulation engine. So I will jump into a project just to show you some basics and to show you what are the options. Please let me know if you don't see the screen, because I will be changing the workspace on my Linux. So I will head up just to one of the projects and I will start the editor. If fonts are too small or anything is too small, also please let me know. And if you have any questions, you can interrupt me at any moment.
I would say that the fonts might be a little too small. So if you could increase that, that might be pretty good.
Yes, for the parts that are necessary to read, I will do that definitely.
Perfect. Thank you.
So for the editor itself, this is a basic project. This is the project just based from ROS2 project template. I mentioned earlier that there is a very simple warehouse in there with some simple objects. It looks worse than most of the things you could usually see in Open3D Engine because the materials are not there. But this is not the point of what I'm showing to you now. What I want to show you is what we simply have here in this template. And what is there? It's just one little robot that has multiple things very practical for the simulation. The robots typically start with a body link, with the first link, and this is where we place all the control for the robot, like ROS2 robot control. This is a part of ROS2 Gem. Skid steering twist control. It's to be able to control the robot not only well, basically with some messages from ROS using skid steering model. There is a ROS2 frame that I mentioned with namespace strategy and frame name. I will come back to it later. And other than that, skid steering vehicle model and some components that are typical for Open3D Engine, like physics dynamic rigid body. Nothing special about it. The same when we think about the visual parts of the robot, it's all built in Open3D Engine, so we didn't have to add anything from ROS2 perspective, from simulation perspective. We just used what's given in Open3D Engine. But then we can go to what's needed for the simulation, like we can add easily an IMU sensor that is already there in ROS2 Gem. There is nothing spectacular about it. You just add a sensor and the sensor is there. You can configure it with some basic settings. You can change the topic, how it's published, and you can start playing with your simulation. So when I start the simulation, I will go back to the terminal just to start RQt robot steering. But first, I will also show you that after starting a simulation, I can already get access to some ROS2 topics. So with the command ROS2 topic list, I can see some basic things like clock that is always there in our simulation when you use ROS2 Gem, because this is something that is published by our ROS component. But you can also see IMU data that is already published by the sensor I added a moment ago. And you can also see CMD bell that is used to navigate the robot. The same for scan. This is the data sent by LiDAR sensor that is a part of ROS2 Gem. So it's as simple as it is. You add some components, you hit the play button, and you can start navigating with your robot. So when I go back to O3DE engine and I give the speed to the robot, it starts moving. And this is basically due to the message that is sent on command vel topic that starts rotating the robot and that starts moving it around. As you can see, it's a live demo, so it works, and I really hope it works for everyone who wants to try it. What's very important then with those null spaces I mentioned a bit earlier is that you might want to add more sensors and or more robots, and this is something I have in my namespace, in my ROS2 frame. So I can go to the gem and I can pull another ROS bot into the scene. Or can I? Oh, all right. So it's a bit of hassle for O3DE engine at my notebook when sharing the screen, I guess. So maybe I will skip it. But what I wanted to present is simply changing the namespace of the robot. So I will restart O3DE engine and I'll do it again. It's changing the namespace of the robot to be able to present the data on different topic. And this is crucial when you have multiple robots. So in the ROS frame, it's enough to start with custom namespace and add, for example, ASDF. Then when I play the button and we can come back to our terminal and we hit ROS2 topic list again, we can see that the topics that were related to the robots are already namespaced. So any simulation engineer can already work with it as with any other simulation, and it's possible with a couple of clicks to tailor the simulation to the setup with real robots and to do what's needed to be done. All right, so I will close it without saving changes. It's nice to stress the fact that I changed the namespace with the override, which is a great feature of O3DE engine when you use multiple robots. You can see the data from O3DE engine in any tool that can present data from O3DE engine. I'm not going to do that now to save some time, but basically it's possible to show the camera image, for example, with your RVs. Another thing that's already there in ROS2 Gem is a robot importer. I created here a screenshot of two different robots. It's animal robot. The one in the background is the one downloaded from the internet. The one in front is with slightly modified materials and with added two extra camera sensors on top of the head of the robot. This is something to also, because I wanted to show that we always need work of some people who love graphics, who can create nice materials, who can create nice meshes, because this is a part of the design. This is a part of the simulation. But for the importer itself, I will open the editor and I will show you how to import the robot and how the importer works. It has some graphical user interface. There is a wizard that allows you to change a couple of settings. I'll create a new empty level. So for the importer itself, what we really need is a file that we use as a base to our robot. That can be, for example, download from the internet, or anything standard can be used. Right now, I'm just trying to import Turtlebot 4 robot, which is an official ROS2 package, which shows our integration with ROS2. The first option in the importer is just to use articulation or joints. Those are the different settings in the physics. There are also some options. I will flip it off. And there are also some options when you import joints, if you want to preserve joints that are not important or not. I will flip it off for the moment, but it doesn't really matter. There are some information about joints that were, or links that missed some data. It's nice to read when you really want to have the robot working. I'm not going to go into details. I just want to show that it somehow works. It copies all the meshes. It tries to find all the meshes, and it creates the prefab. If I click it, create prefab. Yes. And the robot is already there. So with a couple of clicks, I was able to import the robot. And when I start looking into the robot, I can really see that many things, like, for example, LiDAR sensor, together with the parameters, that it was also imported. So for example, you can see the LiDAR sensor that was imported. You can also easily find a camera that is there. And by camera, I mean, of course, ROS2 camera. So someone created a robot in URDF format that was meant to work with Gazebo, and that was meant to work with Gazebo camera, but we can import it. We can convert Gazebo camera into ROS2 camera of ROS2 Gem in O3DE, and we can start working with that directly. When I zoom out, I can see the frustum of the camera, the blue lines that is pointing upwards. It's because the importer is not perfect. And this is something I wanted also to highlight, that importer doesn't solve all the problems. It helps you to start. If you want to get something that is already available online, you just import, and you need to fix a couple of problems, like, for example, the camera that is pointing in the wrong direction. It's pointing upwards instead of in front of the robot. But it's still better to have something than not to have something. So we think this importer is really valuable. And in my slides, I also mentioned that I would import animal and UR robot, but I will skip it because I don't want to run out of time. But what's important to mention is that we can also import Xacro, not only URDF, and that sourcing of ROS2 environment works in this case as well. So if there are some links to components that are outside of the working directory, in theory, Open3D Engine will also find them. All right, I will jump into the code right now to show you something else. For the code, I created a small gem. I will zoom in. So I created just O3DE test gem. I even pushed that to repository, so you should be able to find it. And I used Open3D Engine just to generate an empty gem with the code. And right now I opened Meld, which is a div tool, just to show you what was added to make it working. With ROS2, I hope you can see that, but basically there is a change in private file CMake, and it's because I added 2 files with a test component. So there is nothing really spectacular in there, just adding 2 files that should be built within the code base. I will go back to the component in a moment. In the module, there were more changes because of Clang format. Sorry for that. But the only meaningful change was, in fact, adding the descriptor of the test component. So this is something O3DE developers do on a daily basis. When they add a component, the component has to be registered. So the engine can find it. But the more important part goes into CMake. So what we use in our code base is we link to the static ROS2 library. And for this example, I also link to 2 more libraries because I use them within the code base. But in most of the cases, when you just want to link with ROS2, the only thing you need to do is just linking with the gem. And within our gem, in our CMake configuration files, we also added an extra comment, target depends on ROS2 package. And this one is also used here because we link to ROS2 packages like standard messages, standard services, RCLCPP, of course, and so on. So we link our private object of our code base with those libraries using this special call available in all CMake files of O3DE engine, of course, only after including ROS2 Gem. So the more important part for the test component, I will open it with different files so you can see it better. All right, so this is it, and sorry, it's not really my computer that I use on a daily basis, so I might do weird things, but I will find the file quickly. So it's here, it's projects, and no, sorry, it's gems, test gem code source test component. And I will open those 2 files. All right, so what happens in the code? The only thing we do in the header file, we use the communication of ROS2. That's our implementation for topic configuration. I included this file because I want to use a ROS2 topic. In this example, I will implement ROS2 topic publisher and ROS2 topic subscriber. Of course, I also include some standard ROS files like RCLCPP and 2 files defining the services, standard services and standard messages. I try to make some names a bit simpler to use with using directive, and then there is a code base that is very typical for any component you might want to have in O3DE engine. So of course we use a component as a base. I will also handle tick bus because I will use it for publishing data. There is a registration of the component, of course, constructor, destructor, reflect method as I would normally do. Activate, deactivate, I will show you the implementation in a moment. And there is, of course, onTick method, which is an override, and tick bus handler. So in this example, I implement one service, which is defined exactly like in any C++ ROS2 implementation. There is nothing different than in any code you would type when you want to implement something related to ROS2. I use additional variable for the name, service name, and I use additional variable for the entity ID because I will have my service to turn on the lights. I will also have in my code base a subscriber, which is again the implementation like in any ROS2 code, and I will also have a publisher, which is similar to subscriber, standard ROS2 implementation. And the thing that comes from ROS2 Gem is just ROS2 topic configuration. I use it to make it easier. There is also a method for setting the lights intensity, which is my helper method when I start playing with the code. All right, so for the component in C++, stuff that is always happening in O3DE engine when you want to have something visible in editor and when you want to be able to serialize stuff. So first of all, I serialized my fields to be able to save them. And then also for the edit context, I list all the configurations that I want to be able to change in the editor itself. So here I just have a subscriber configuration and publisher configuration for the ROS2 topics. I will show you how it looks like in a moment. And I also have my entity ID for lights, and I also have a simple string for a service name. We require a ROS2 frame when we want to have this component. So this is added in get required services. And within the activation node, activation method, I start all the ROS2 nodes and services and topics that I want to have within this component. So first of all, I check if ROS2 node is present. If the ROS2 node is there, this is a part of ROS2 Gem, and I only do a check to be sure that the gem is loaded, and just to be sure that there is no null pointer problem causing a seek fault later. And it's exactly the same for ROS2 frame. The frame component is required here, so it should be there. I use ROS2 utility to get this game or editor component. This is something extra we wrote to make the code slightly simpler. I'm quite sure it's possible to do it with built-in O3DE engine methods. However, when we designed ROS2 Gem, maybe we were not familiar with them, and it stayed like that with us. So for the service, what I wanted to show is that the code implementation is, again, exactly the same as anyone would write for ROS2 service when implemented outside of O3DE engine. So basically, O3DE engine integration with ROS2 is seamless. We have our service name that we get together with the namespace using this additional method. And based on the service name, we create a service, and we implement all the methods for the service, which is here. We have our trigger, we have our response for the service, and in the body of this method, we check if the lights are there. And if the lights are not there, of course, we can already fail saying that we cannot turn on the lights because the entity ID is not there. If the entity ID is there, so otherwise, we simply use the method that I implemented as a helper function that sets lights intensity with this target intensity 500 lumens in this example. And we can check if this method returns Boolean. So depending on the method being successful or not, we can also set a message. The same for topic subscriber and topic publisher. The only thing we need to do is implement the code exactly as in ROS2. So we create a subscription. We use a float2 message because we will just send intensity value. And I use the same method, the same helper method that set lights intensity with target intensity being read from the ROS2 message. For the publisher, the only thing that happens here is creating a publisher, because I will be calling the publisher in onTick function. So the activate function terminates those ROS2 nodes. Here, of course, it disconnects also the tick bus. My implementation of the helper method for setting lights intensity, it uses built-in O3DE engine bus to set intensity and mode. Not sure why set intensity didn't work in my case. That's why I use this one. But basically what happens here is that I set the intensity, then I read it with the request, and I compare if the red value is as set, and if so, then I assume the value was set correctly. I mentioned that I published the ROS2 message within onTick. It's not very efficient because we don't want to publish it in every onTick. Normally, we would publish it with 10 hertz or something similar, depending on the requirements. What I do here in my publisher is just I check the intensity value, I create a ROS2 message with this intensity value, and I publish it. So how it works? I will open the editor and I will show you how it works. As a small example, so there is an empty level. I will just create the entity. In this entity, I will add light component, and it's a sphere. I might change the color to red just to be sure that I changed something and that it works correctly. I'll put it a bit in front of the shader ball so we can nicely see the light on top of the shader board. The intensity can be set, let's start with 100. And besides that, I will also add another component, which is the component I created. I call it a test component. And this component requires ROS2 frame. That's why it's not active yet. I add ROS2 frame. It's there. It has my service name. It's simple string, so it's serialized as another string. I can call it just, service name is perfect. I have also my subscriber configuration and publisher configuration. So this is how ROS2 topic class is deserialized. It has some parameters for QoS, which is typical for ROS2, and it also has a name of the topic. So I will just use topic for subscriber, so topic underscore sub and topic underscore pub for the publisher. And again, when I start the demo, I can open the terminal and I can already show ROS2 topic list. With ROS2 topic list, I can see entity 1 topic publisher, entity 1 topic subscriber. So this is there. When I go for ROS2 service list, I can see that there are few services generated by O3DE ROS node, but there is also this entity 1 service name. If I start the simulation and I change the way the namespace is created by ROS2 frame, which is I will change it to empty, then we will see the change directly with ROS2 service list, and the first service, the last is just service name. So ROS2 service call, I can call the service name with a trigger command because the service was of a type trigger. It should change the illumination to 500 lumens, and it doesn't work because it didn't find the entity. So I got a response which is false, and I got a message, cannot turn on lights. So yes, actually I added a light to exactly same entity as my component. So I will just add it here and I will start the simulation again, and I will go back to the terminal and I will try again. And probably you see that it's a bit brighter right now. I can also ROS2 topic echo, and I think it was topic pub. So I can see that it's 500, it's published all the time. I can also ROS2 topic publish. I was testing the demo a bit earlier, that's why I have all the commands in my history. Of course, I can change it to 250, I can change it to 25 as well, and it works as expected. So the nice part is that I could do exactly the same. I will just close the editor. I could do exactly the same from the ScriptCanvas or from Lua. And this is done with ROS2 script integration gem. So this is a separate gem that is also open source provided by us, and you can use it directly. For Lua, it's just one line of code. It's just publishing a string message on topic hello with text hello from Lua. It's in ScriptCanvas, it's very similar. The only thing we need is a topic and a value. here in my canvas, you can also see on graph start and heartbeat, because when testing it, I was just checking if it works as it should every frame. It's slightly more complicated when you want to subscribe to a topic. And this is solved in a way that in Lua, we connect to this std msg string, so standard message string on topic input. Before that, we connect to the bus, of course, which is subscriber notification bus. And then we simply overload a method on standard message string. And then when the message comes, we would, in this case, just see the back message with the text. Similarly, you can do it from ScriptCanvas. Graph starts, we subscribe to string on topic input, and then there is an event coming on subscriber notification bus on topic input. And if the message comes, we get the value and we can print it here in the back message. But of course, we can get in the same way, we can get float message, and we can use this float data to do anything we would like to do. Right, so I was very slow with my presentation, and it's because I was doing it for the first time. I wanted to show you quite some demos, but because there is not much time, I will skip this part for a moment. But the important part to say is that we also have hardware in the loop demos. We do a lot with segmentation, and segmentation can be done as trivial as just changing colors of different objects in material editor. There is also open source gem from our group that allows you to change the weather and to change the time of the day with sun going around the sky. I really recommend you to check our YouTube channel with all those videos. And this is something I wanted to mention. We don't have that solved yet within Open 3D Engine community, but there are many gems provided by many companies. And I'm listing here only robotic AI company because I'm a part of this, and this is what I know the best. And this is the first link is about robotic O3DE tools, which is full of different tools providing you different options to do different things, like the one I presented a moment ago, which was about ROS2 script integration. We have many tools for cameras to record nice videos, to smooth the cameras, to be able to switch the cameras. There is also a vehicle dynamics gem that allows you to drive a car on the level with a keyboard or with ROS2 controls or with anything else. It's a very simple simulation of a car that can be very practical when simulating the city. There is RGL, which is a Robotech GPU LiDAR, which allows you to use LiDAR sensor on a GPU and to make it really fast, and so on and so on. Couple of gems with robots, gem with a human worker that can walk around the space. There is a gem also for generative AI. It was our try from the last year. I really recommend to try as much as possible. And the same with different assets. On our repository, you can find a couple of open source gems with assets like barrels ready to be pulled into your project, to be used within your project. And for sure, something you should try besides templates is projects. There was a robot vacuum sample demo on ROSCON 2 years ago, 3 years ago, sorry. 2 years ago, there was simply ROSCON demo. There was a ROSCON demo last year with 2023 on top of it. And there were many different demos using RAI that are also open source that were there this year, which are RAI agriculture, RAI ROSBot, RAI manipulation, and there are even more. So I recommend you, if you want to start with simulation, start with a template or start with any of the projects and just try playing with ROS topic, trying to add a bit more of subscribers, publishers, and basically that's it. As mentioned earlier, I wanted to show you some videos, but we don't have time for that. So I recommend our YouTube channel, LinkedIn channel, and other channels of communications. You can also ask me questions on SIG simulation or right now if there is still some time left.
Already have some answers, but I wanna hear from Jen about AI and behavior tree and path planning? What are they using to control kind of the AI of the robots?
We have really different projects. We have different clients because very often we simply use tools that are built in ROS2 for navigation. We are for non-playable characters. We use things that are built in O3DE engine like Recast Gem. So depending on what we need, we use different tools. For AI, we even let AI to see what camera would see, and we ask the question to AI, where would it go? And AI answers a lot to the left or goes straight. And we also convert those into comments on ROS2 that would navigate the robot. I'm not sure if this answers your question.
No, it's fine. I guess it looks like it's all kind of externally controlled from the engine. Basically, the AI is not in the engine, it's outside and it's controlled
Yes.
with messaging. Yeah, okay, good. Thank you.
Yes, I have one more thing to add. I'm always there, or at least I'm trying to be always there for 6 simulation weekly meetings. It's on Thursday. It's probably a bit early for many of you being in the US, especially on the West Coast. But we are based in Europe and we have slightly different time zone. So you can also come there to ask me questions. I will be very happy to answer those questions. Typically, we just go through the issues, but there is always a lot of time left for us helping out. And by us, I mean myself, Steve, who is also participating in those meetings, and some other folks from Robotech AI.